Good morning, it's me, Mr. Treewind. We're back here for another lesson in geometry, and today we're going to be looking at something called a biconditional. This will be a short little segment because it's not a lot to it, and we covered pretty much all the parts of it yesterday. We just got to put them together to finish this up. So yesterday we went over something called a conditional statement, and that was a statement that had an if and a then, where if represented the hypothesis, and the part following then represented the conclusion. We called these P and Q, P being the hypothesis and Q being the conclusion. And then we said yesterday we covered another little topic called a converse. And this is when you take that conditional statement and you reverse or you switch the hypothesis and the conclusion. Now we do this to figure out whether or not these are good statements and if they're true statements. And so one of the reasons we're doing this is to learn to write better definitions of the different terms that we're going to be learning in geometry. And then things outside of geometry, when you go on to something else and you have to write definitions or give directions to people, having a little understanding of a conditional statement and a converse will help you do that better. So for our first example, we're going to look at something that I'm going to give you a conditional statement, and what we're going to do with it is we're going to see if it's a true statement, and then we're going to try to do the converse. Now, if both of those are true, we're going to combine those two to make something called a biconditional, which is a way for us, it's kind of like a rule, if you will, to help us learn a new term in geometry. So we write biconditionals when we're learning new concepts. It helps us kind of define them better. And so let's go over this. Here we are. So here's my example. If all angles in a triangle, and excuse me for using a lot of abbreviations and symbols, but I'm getting lazy here and I'm trying to get us introduce them as we go. If all angles in a triangle are congruent, then it is an equilateral triangle. That's a true statement. I like that statement, so I'm going to give that a true on the truth value. All right, what if I say that statement backwards? If I reverse the hypothesis and the conclusion, and I say, if a triangle is equilateral, then all angles are congruent. Again, we gotta shorten these here and there sometimes just to make them make sense. So we talked about this yesterday, give or take a few words. All right, so if all angles in a triangle are congruent, then it's equilateral. If a triangle is equilateral, then all angles are congruent. Okay, that's a true statement again. So that means that we can combine these two to make something called a biconditional. And when we write a biconditional, we stop or we drop the whole if then and we just make it a sentence. Well, in that sentence, we're going to have to include one key term, and that is if and only if. So let me write this out, and sometimes I have to think it over, make sure that I can make it into a complete sentence so that it makes sense. But let's say it says if all angles in a triangle are congruent, then it's equilateral. And I would start off with all angles are congruent if and only if it's equilateral. So maybe if I just, all angles in a triangle are congruent if and only if are congruent if and only if it is equilateral. All right, so that is called a biconditional statement. And again, we use them to kind of lay down definitions for us that we can use to learn all the new concepts in this class. On the example number 2, I want you to look at this one and see what happens when I look at this statement. The first time I say, if you're 16, then you can get a driver's license. That is a true statement. If you're 16 here in Florida, you can get a driver's license. But what happens when I say that as a converse? If you get a driver's license, then you are 16. Are you sure about that? If you get a driver's license, then you're 16. Lots of people have driver's license. It doesn't imply that they're 16. So when I say that as a converse, it's not the best definition, and it tells me, hey, you need to rework this and get some different terms to define it, because when you say, if you're 16, you get a driver's license, that does sound true, but when you say it in reverse, it doesn't do so well. So in this case, I cannot combine this for a biconditional. So I'm going to say, true, and then the second one being false. So converse is false. And therefore, I cannot use this to make a definition, so I will not use this as a biconditional. So whenever we say one of the sentences is true, or whenever we say one of the sentences is false, we know that we cannot do a biconditional. So that concludes our little lesson on this. Really short video. I just want to make sure that we have it on our team or on our Canvas page that we can constantly look at and reference. So thank you. See you later.